This is a video about how to solve problem 11.27. In this story, they're trying to figure out if two different regions have significantly different causes of types of forest fires. So the reasons for forest fire are whether it's arson, accident, lightning, or unknown. And counting the fires, here's the data. So the question is whether the cause of the fire is independent of the region. And so our null hypothesis are region and cause of fire are independent. And the alternative hypothesis would be that they are dependent. We're going to use a chi-squared, and our level of significance is 5%. So for our chi-squared test, we need to have an expected value for each category. So this comes from row total times column total over the whole sample. So those totals for region A, the total is 31. For region B is 45. For causes of fire, it's 13 from arson, 23 are accidents, 21 is lightning, and 19 is unknown. So if we are doing region A and arson, then we will have 31 times 13 over our overall total is 76. So for region A, expected value is 5.303 with regard to arson. So that one is right here. I'll do one other one. Let's do region B, unknown. For that case, expected value will be 45 for region B, 19 are unknown, divided by 76. This will turn out to be 11.25. So, and is associated with this. So we're going to, associated with this category. So we're going to need 8 different expected values. So I'm going to put them all in a column. Here's expected. Here's observed. And the first one we just did was 5.303, which goes with arson. So there's going to be 4 for region A. And then there's going to be 4 for region B. So there's a lot of categories in this one. So the one we just did came up with an expected value of 11.25 for region B and unknown, which had 9 observed fires. So this is B with unknown. When it's B with lightning or B with accident, B with arson, A with unknown, A with lightning, and A with accident. So now I'm listing them all in a column style in order to complete this. So the observed were 9 and 6 and 10, and the observed here was 7 and 14 and 15. And so what the expected values will turn out to be is 9.38, 8.57, 7.75, 7.70, 13.67, 12.43. So observed minus expected squared is going to be a column, and then observed minus expected squared divided by expected. So we need the total of this last column to find our chi-squared test. So just filling in what these need to turn out to be. These turn out to be observed minus expected squared will be 0.49, 0.15, 6.58, 5.06, 0.49 again, 0.15, 6.58, and 5.06. After they're divided by this expected value, it becomes 0.09, 0.02, 0.77, 0.65, 0.06, 0.01, 0.53, and 0.45. So that when we sum this last column, we get 2.58. This problem had a significance of 5%. And looking at degrees of freedom, row -1, column -1. So we only had 2 rows because we have 2 regions. We had 4 causes of fire. So that's 1 times 3 is 3 degrees of freedom. With 3 degrees of freedom, the critical value becomes 7.815 as the beginning of the rejection region. Whereas our test statistic was only 2.58. So our conclusion is do not reject the null at 5%. Which means that we cannot show that region and cause of fire are statistically dependent.